So far we are moving towards the end of the presentation for this session today. And so far we have completed like robotics platforms, micro resolutions, quality by design, and now the time for the last presentation of the session is on artificial intelligence. So I'm delighted to introduce Mr. Sandeep Kulkarni. He is scientific director of Image Provision Technology Private Limited, India. Sandeep Kulkarni, by education, is a mechanical engineer from the NIT and a management degree graduate from the IIM Ahmedabad. He has also undergone a special course in image processing from Duke University. Sandeep has more than 31 years of experience in diversified business and held senior positions in reputed companies. He has extensive experience in the manufacturing, setting up and running the manufacturing plants. He has set up three greenfield factories, including implementation of various ERPs and other IT systems. After spending 22 years in the professional life, he began his entrepreneurship journey. Image provision technology in his entrepreneur ventures, he has built image provision to a well-known image in the image analytics area. The company has developed unique physical testing products with emphasis on image analytics. Image provision, innovative product in microscopic particle size and shape analysis is used by many top pharma companies in India. Image Provision has initiated 5 patents in this field and won several awards. Winner India Pharma Awards for the most innovative product in pharmaceutical machinery category in the CFHI 2015 Mumbai. Winner of Shark Tank, Best Startup Company of the Pune. Winner Top 50 Upcoming Companies of India by NASCOM Bangalore. He is very enthusiastic in the field of training and teaching. Now, Sandeep always finds opportunity to interact with the people and extend his experiences. With this, I am inviting Sandeep to talk on the topic artificial intelligence-based particle characterization and its influence on the dissolution testing. Over to you, Sandeep.
Right. Thank you very much. Thank you, Dr. Kailash, for a nice introduction. And I hope I'm visible and I'm audible.
Yes, yes.
Yeah.
Yes, please go ahead.
So thank you for getting me in this program. And before starting, I'll just say that with the help of all the love and affection of all our customers, 110 customers back in India, I'm sitting today in US with opening our office in US. So that's thanks to all my customers. I just share my screen. Let me know. Is it visible? Yes. So thank you for joining this session, important session. I'm sure that all of you have enjoyed the last 2 days and some of the sessions today. And have deep learning in the dissolution science. What a wonderful collection of all top brass in this field. And I would like to thank DISSO India and especially Dr. Ramaswamy for giving this opportunity to talk to you and this topic. As I don't have to tell again, but I'm Sandeep Kulkarni. I'm representing my company called Image Provision Technology. And the topic on which I'm going to talk is the artificial intelligence-based particle characterization and its influence on the dissolution science or dissolution testing. So I don't have to tell all of you that what is the role particle properties play in any drug substance. I mean, you all better know about it, but some of them I'm just listed down here that if you want to better control on the product quality, you want to improve the product performance, it's important that you understand your particle properties properly. Troubleshooting the manufacturing and supply issues, one of the very important area where sometimes we struggle to find out why one batch is performing better, the other one is not. So once you go back to the particle properties of every batch, probably you will know more about your particle details. Better understanding of products, ingredients, processes, optimizing the efficiency in manufacturing process. If you know your particle properties better, you can optimize your manufacturing processes as well. Yield improvement, staying ahead in the competition, some of the other factors. Right. What is the role of particle characterization in pharmaceutical industry? In pharmaceutical industry, the particle size distribution, and particle shape or morphology of active pharmaceutical ingredients, APIs, is known to strongly affect the stability and aesthetics of the formulation. Now, the size and shape of particles used in pharmaceutical drug product, not always, but most of the time, impact the dissolution rate. And let us try to see how it impacts. So here are a couple of examples. What we are doing is comparing the biopharmaceutical properties or apparent dissolution of different batches of API and SR granules. So I have some one batch where APIs have mean diameter, three batches, one with 128 micron mean diameter, the other one is 135 and 120. If you look at the dissolution profile, I mean, more or less similar, because there is not much difference in the particle size, and within no time they get into the 100% dissolution. Interesting is to look at this SR granule example, where one particle is with 675 micron size, the other one is with 625 micron size. If you see that 625 micron size has gone to the 100% dissolution, where on the same time your 675 has got to almost 80% side. So we know that particle size plays an important role in dissolution of any drug substance. Let us take an example of particle shape, although we are going to get into more details on the particle shape, but this is one example. Just wanted to show, for the same substance, there are two different types of particle shapes. One is fine particle, the other one is needle-shaped particle, and the dissolution profile is different for both of them, although the size is same for them. So why this is happening? Let us try to establish the correlation between dissolution and the surface area. So dissolution of drug substance depends greatly on surface area. If you look at this equation, rate of dissolution is equal to surface area of the interface times diffusion coefficient and boundary layer d by d, and then times the difference of concentration of substance on surface and concentration of substance in the solvent. So for us, this surface area is an important parameter when it comes to the rate of dissolution. So let us look at it, how this affects. So what it happens when we reduce the particle size. So it's very simple example. This is a particle with continuous this volume. If I break this particle into two, the volume or the mass is not going to change, but we have got two new surfaces here, which increases the surface area. And that is where, for the same volume, you get more surface area. So as you go on reducing the particle size, your surface area increases to a large extent. And that's how you can control your dissolution based on the particle size. Let us look at this very interesting example. What we have done is, for 1 kg of one particle, we have changed the particle diameter, and let us look at what kind of changes it happens in the surface area. Like for 1 kg of particle having 1000 micron diameter, it's very low surface area. But for the same 1 kg, if I'm reducing the particle size, let us say if I come to the 100 micron, the surface area is as good as a parking space. And if we reduce further to around 1.1 micron, as good as a football field, and when it comes to more than less than 0.01, for the same 1 kg, you can get the surface area as big as a Disneyland surface area. Okay, so that's how you reduce. This plays a major role in particle in surface area, increasing the surface area and thereby increasing the rate of dissolution. Now, this is very important, where I want all of you to take a little more concentration in this slide, because now we all know that particle size plays an important role, but how particle shape plays an important role in increasing the surface area and thereby the dissolution. Let us look at it. Now, since there was no technique, immediate technique to get the details of particle shape, all the time we are correlating our dissolution profile or dissolution testing with respect to particle size. But let's just look at what particle shape plays. What I've done is I've taken 4 different geometrical shapes: sphere, then this is cube, this is cuboid with the sides 2:1:1 ratio, and this cuboid more of a flake kind of structure, 4:2:1. And keeping the volume same, that means what happens is when you're doing the particle size analysis using a laser diffraction technology, you will get the particle size same for all these shapes, because my volume is same. So it will convert what laser diffraction does is it approximates every shape into an equivalent sphere, and the diameter of that sphere is given as the particle size. So let us look at the particle, the surface area for these shapes. So for any same volume, the surface area of a sphere would be minimum. But this, if you convert the shape of your particle into a cube, the surface area increases by 24%. And if you go to this size, this shape, almost for the same volume or same mass, you can increase the surface area by 45%. So that is the emphasis I wanted to tell you on the not only particle size, but particle shape plays an important role. There's one more example where we are looking at the sphericity. It's more sphere, more particle 0.97 sphericity will have this dissolution, whereas a little rough particle with 0.87 sphericity, because it has got a lot of spores, the surface area increases, the dissolution rate increases with that. So these are a few examples by which we are understanding that particle shape is one of the important factors in dissolution testing. So how we can define the particle shape? Now, it's a morphology basically, and it's defined in various ways, like ferret's maximum diameter, ferret's minimum diameter, circular equivalent diameter, circularity, solidity, convexity, aspect ratio, and major axis. So these are the ways. If I know these all parameters for any particle, I have better control on my particle properties and thereby in the dissolution. So do we have any technique which can provide us all these data very quickly and very accurately? So here we have one solution which we have given to our customers. It's an automated digital microscope. So any microscope of any make or model of microscope, you put a camera on it and hook it to our software. You can convert it into a particle analysis system. What our system does, I'm little going quickly because of the time. So this is how it works. Basically, you take the image from the microscope. The left side is showing the input image. What my software does is first of all, it identifies each and every particle, and then it classifies in terms of isolated particle and agglomeration, which is a major development in this field. Because in other technique like laser diffraction, it will consider everything as a particle. And that's why our major focus in those techniques is preparing a sample such that there are minimum agglomerations. But here, since we are able to differentiate isolated particle and an agglomeration, I don't bother too much about the sample preparation, although we should prepare a good sample to have more isolated particles. But if at all there are some agglomerations, I'm not bothered because I can populate the statistics for agglomerations separately and for isolated particles separately. This has given a paradigm shift in terms of particle characterization that we can not only get particle size. Since I'm able to see each and every particle, I can get the shape of that particle. And with further development, what we are now able to do is that within those isolated particles, we can get the particle like APIs, excipients separately in a single analysis. And this classification is done based on optical parameters like size, shape, color, texture, intensity, to name few, but there are multiple parameters by which we can do this classification. This is how the system looks like. You can prepare a sample, put under the microscope, keep on taking images by shifting the stage, or if you have a motorized stage, it will automatically do. All live images appear in the screen. Based on your classification parameters, it will differentiate those particles in terms of API, excipient, agglomerations, and populate this table on the fly. As you are taking the images, it will convert, like it gives like count total 8,900 particles, out of which 164 API, so much are excipient and agglomeration, minimum size, maximum size, standard deviation, and percentages. You can also get the D10, D50, D90 for individual particles. And it generates histogram as you're taking the images. It identifies particles and collates the data, and quickly, within fraction of seconds, you get all these data. This is an important graph where what we plot is that D10, D50, D90 graph, which gives the indication to the analyst that I have come to a stabilization level. So when this graph becomes stable, that means we have taken enough particles which represents this sample accurately. If I take more images, the D10, D50, D90 is not going to change much. So this with this analysis, what we have found, the customers are very happy because all the required information for which is required for them to take any decision is available in a single screen. Along with particle size, morphology of particle, we give that you can actually see each and every particle, how it looks. And there are 14 different parameters which we populate with every report. And this, it has got all the 21 CFR requirements. And that's why we give it can be not only used for your R&D purpose when you're developing a new drug, but it can also be used as a QA/QC tool for release method. So a lot of our customers are using it for both the purpose. Now, this is an important and very interesting study. What we have done is that we had a customer who had API supplies from two different suppliers. Both of them were claiming the same particle size in terms of from the laser diffraction, and but the dissolution profile is totally different. So why this is happening? So when we run both the samples from our system, what we found is that the particle size and shape is very different. Because of shape are different, they are, I mean, laser diffraction could not detect the difference. So when we run the particle shape in terms of the length, that is ferrite maximum diameter, it gives a different dimension altogether. So if you can see that source 1 has got 6.59 D90, while the source 2 has D90 13, and the dissolution is very, very different. So this gives a lot of advantage when you're developing or you are producing a drug. This is being used by many companies in different ways. They are comparing the batches, various batches, how the performances these batches, and try to get more details on the particle properties. And then you can correlate the data. So there is what is new in this. We have come out with a new technology in microscopic particle size and shape analysis. This entire system is in cloud platform, and it is powered by machine learning and artificial intelligence. So when it goes to the cloud, you get flexibility that a big pharma company can have this in their private cloud. You can connect all your microscopes in R&D or in manufacturing in a single platform. Or if you want to join in as an individual user, like a student in a college or a consultant, they can just go into the public cloud and get their data or their analysis done. All the data is very secured environment. Data is in data encryption. There are triple encryption in that. There is we follow all 21 CFR compliance norms in that. Although it's a very complex system, but I'll try to explain you in a simple manner. So what we have done is that this is the basic process flow in particle analysis, that we take the image from microscope. This image is pre-processed, then particle is identified, and then particle is classified, and then you generate the report. So we have put two machine learning engines here. One engine does the screening of quality of image. So as you are taking image, whether this image is good enough for analysis or not, that is done by this machine learning engine. And once it is qualified, the second machine learning engine classifies these particles. So all particles are identified based on the particle training. It classifies into API, excipients, and then you get the statistical analysis is done. And all this goes into the artificial intelligence engine. So that what happens is, as you are using the system more and more, you get more, your system becomes more intelligent. So you run a batch, you're done multiple analysis, all this data goes into your particle training and database. And when you do the new batch, it will automatically identify those particles and classify those particles in terms of APIs and excipients and other things. So this is where I was saying particle training is an important module in this. What the system comes with inbuilt or the particle training modules of various particles in default mode, but you can train your particles also. So let's say you've got a sample, you've taken various images. Now you know that these are my API particles. Just put those particles into API bucket, others in the excipient bucket, and then agglomeration. And the system automatically trains itself so that it identifies these are your API particles. And when you run the formulation, it will identify those API particles very accurately. There are various ways you can use the system. I'll not get into the details, but these are the very rich analytics what we generate, not only on the particle size, but you can differentiate what are the various agglomeration percentages, how much, APIs, how much, and other details like D10, D50, D90, not only D10, D50, D90, you can get D1 to D100 all data populated here, and other morphological details like this. So here what we give is, for every particle, we give many parameters, what I explained. So you can understand your particle quite better with this. And since it's in the cloud, as I explained, it is now anybody can reach to the system, and it works on a SaaS model, that is pay as you use. So it is very useful for individual users also. So that comes to end of my presentation, and thank you for listening to me. I hope I could give some of the insights about this important topic on particle characteristics. Thank you very much.